I'm on page 608, and we're taping this for a few people that are gone, so hello people. Geometric sequences are sequences where the jumps are by a ratio, not a difference. Yesterday we talked about arithmetic sequences, which go like this. They have a common difference of 3 for this one, for instance. If it jumps by a common difference, that's arithmetic, that's yesterday. Today it's going to be geometric. Geometric sequences do more like this, where they are times by a same ratio every time. So the jumps are not the same size, but they do have a pattern yet. They're times a certain number. Grab your paper. We're going to start an assignment that is called 10-3, 2 to 63 evens. That's 10-3, 2 to 63 evens. We'll check that on Tuesday. Let's start doing it together. I'll do like a sample from each part of it. I'm going to have my friend Ben. He's going to look at number 2 there. He's going to try to figure out what they're doing. It goes a half, -3/8, then it's 9/32. Ben, can you see at all what they're doing?
It's we multiply by -3.
Nice. Ben has cleverly separated the top from the bottom. He looks at the top, he sees it goes times 3 every time. He looks at the bottom, he sees it times 4 every time. He noticed there's a sign change every time. So because of the top, he's saying this. Because of the bottom being times 4 every time, he's saying that. And since he spotted a sign change every time, he's saying the ratio, the times or factor, he's saying it's -3/4. It's a good call, Ben. And he has to find the next 3 terms. Gonna help him with that, Billy?
It's going to be 27
27,
over 128.
100,
28.
128. This is getting out of hand.
No. And it's going to be 81.
81, I was thinking that.
Over 500 for.
Or 512, nice.
It has to have no.
Do we have to put some negatives in, you say?
Yeah.
Which ones?
27
This one has to be negative.
243 over 1,536.
That's negative also, right? That's how those work.
No, it's not 10 to bottom. Has to be 1536. Let's just take it.
The bottom is what?
To 2048.
2048. All right. We're making it harder than it is. Now we will jump to number 10. I'm going to use Nate here. Nate, I'm looking at that number 10. It goes 36, 12, 4. 36, 12, 4. First off, I gotta ask you, Nate, do you see what they're doing?
They're divided by 3.
Dividing by 3 or times 1/3, whichever way you'd rather think of that. So you're right. So now we have to write two formulas for this, for A sub n, a recursive and an explicit. The recursive is usually kind of easy to write. You just write down A sub n equals, and once you've decided what it's doing, you put down A sub n minus 1, which is the last one. And then right here you put what's being done to it. And Nate says times 1/3. Or you may have divided by 3. That's just as good. And then for the recursive kind, you have to tell where it starts. So you put A sub 1 equals 36. This would be the recursive description. Now, the explicit description would be nicer, more useful, because you could jump straight to the 10th term if you wanted to, you know. And on the geometric kind, that goes something like this. I'm going to put that up here. So A sub n is equal to something times, and then right in here we'll have a parentheses. And then up here we have to put how many times it goes times 1/3. So if it goes times 1/3 twice, we would put a 2 there. So this is going to be n minus 1, because you don't do it to the first one, you see. Right here I have to put my starting number. What does it start at? 36. So can you see that to get the second one, you got to go times 1/3 once. To get this third one, you can start with 36 and go times 1/3 twice. So if n is 3, we go times 1/3. It's always off by 1 because you don't do the one you started with. That's the one you started with. So this jump is times 1/3, times 1/3. But it's always the jumps, how many jumps you've made, you see. So that'd be recursive, that'd be explicit. All right. Then I would like to show you how to do a kind like number 20. 20 says 60, 30, 15.
Wait, so the bottom one is recursive?
Yes, ma'am.
What number was that, Mr. Barth?
That was 10, I think. To catch you up here, Caden Connor, we're doing geometric sequences which are timesing by something. Looks like this one's times 1/2, right?
Yes.
And what we're saying is that you could finagle a little explicit formula for that. The nth one is always going to be equal to the first one. You with me? With me? Times, what's the ratio then, Cade?
1/2.
Nice, nice. The boy is fully present. And as you were entering, as you were coming in, I was trying to explain that it's always off by 1. So if you want to get the 5th one, you'll have taken it times 1/2 4 times. So in other words, it'll be 4 jumps to get to the 5th one. So we're going to put this not n times, but n minus 1. That makes that right. So the actual question that we're doing now is number 20, where they're asking for a sub 9. You can just now utilize your calculator and go 60 times 1/2 to the 8th. You see, that should get you there.
Is it
Or-
like 1/2 to the 8th times 60, or is it like 30 to the
No, just like it is there. I'll wait for them to get, did you get a decimal answer?
Yeah.
The book has a fraction answer.
15 over 64.
How'd you do that, Nate?
Math.
No. Nate has a math button where he can undecimal and go to fraction. 15 over 64. Where's that button, Nate?
It's right under alpha, the green one.
All right, Nate says you can switch it, you can force it to do fractions. We're now panning over to the grate, Nate. Nate's gonna show you how to put your calculator in math mode.
Yeah.
How does, well, go back out and back in for them.
So that's the decimal,
Yeah,
and for the fraction, math. Enter. Enter.
nice. Thank you, Nate. Now we're gonna go do another one. We're gonna do number 32. In number 32, they have a 4. 2 means, that means 2 missing numbers. And then they have a 256. And we have to figure out the pattern and insert the missing numbers. I would say the first step on that is to figure out how many jumps that was. Well, it's one more than the number of missing means. It's going to be 3 jumps to get from 4 to 256, you see. Now, back when we were doing the arithmetic, we would just subtract to get that. Well, these aren't subtracting, they're not adding, these are timesing, you see. So we have to do a 256 divided by 4. So that's 64 times 64 gets achieved in 3 jumps. In 3 jumps, we go times 64. How can you decide what number times itself, what number you can take times 4 3 times to get? Say that again. Alright. 64 is equal to some number, maybe I should use R for ratio. 64 is R cubed. 4 times R times R times R would be like 4 times 64. So Laura is correct. Use the root feature and find the cube root of 64. Is it 4?
It's 4, but you wrote it. 3.
Oh.
Yeah.
Yeah, thank you, Connor. Connor is alert again. I like it when he's alert. Now we just have to fill in the missing ones. It's not too hard once we know the ratio. It's times 4, so just put in our 16, 64 by going times 4 times 4, now that we figured out it's times 4. So they were really asking for these two numbers, but we had to do a back figure to get the ratio first. Next, the sum of a geometric series. Yeah.
Could you do one more of those?
Another one, I'll do an odd for you if you'd like.
Yeah.
Go ahead and pick it.
We're only.
Wait, you said you'd do it now.
Yeah, 59.
39 is just letters, so that's a little different.
What is the I?
Yeah, what?
And 38.
For 39, you've got 4 means between T8 and T negative 7. One, two, three, 4 missing values. And we know it's geometric, so it's going to be done by timesing. But this is kind of almost easier because when you multiply, exponents add, right? Or in this case, they subtract. So, how many jumps is it? 5 jumps from a 8 to a negative 7. How much are we subtracting each time then? How much has been subtracted in all? We got people thinking 15. So if you're going to subtract 15 in 5 jumps, isn't that 3 each time? So this one is almost easier. I don't know if you really wanted to select this as your feature question, girl. You want to do another?
So what do we say for like
The ratio? Does it ask for the ratio?
Yeah. Or no, we don't have
Okay, but if you did, it would be times t to the minus 3.
What do you,
Yeah.
for 38, when there's an I, what do you do for that?
Well, it's kind of the same. Just remember that an I squared is negative 1.
Okay.
That should help. Do you want to ask another one, like say 37?
Yeah.
All right. 37 starts with 48, and it ends with negative 750. And it looks like there's 2 means or 2 missing ones. I will ask Connor, how many jumps does it take from 48 to negative 750? How many jumps? He's right, that's 3 jumps. Kaboing, kaboing, kaboing. And these are not add and subtract jumps, these are timesing jumps. So we're going to do negative 750 divided by 48. Let's see what that looks like in math mode. We should ask Nate for that.
Negative 125 over 8.
What Nate is saying is that those 3 jumps together accomplished a negative 125 over 8. So what number times itself 3 times gives you negative 125 over 8? In other words, that's 3 r's times each other, right? So we just have to figure out r from that. We just do a cube root of negative 125 over 8. Looks like that one's going to be negative 5 over 2. So Lindsay, I think if you took this times -5/2, you'll have that one. And if you take that times -5/2, you'll have that one. You want me to do it?
Do you always have, do you always have to do like a cube root after you?
The only reason it's a cube root is because it was 3 jumps. So
Oh.
no, that won't always be.
So if there was 4 jumps, you'd
Yeah.
do like that.
That's a pretty good question. It's however many jumps besides the root.
Okay.
Very good question. Is it time for number 40? Three plus 9 plus 27. For this, we have to add up, they say the first 6, and they'd only but tell us the first 3. So we gotta figure out the next 3 and add them up. Notice they call that a geometric series instead of a geometric sequence. If you add them up, it's a series. If you're just trying to list them out, it's a sequence. We have special formulas for that, in case it really gets long, you know. Turn to page 612. Special formula for the series of n terms is a sub 1 times 1 minus r to the n over 1 minus r. Connor,
Yes.
what's a sub 1 here?
3.
Nice, nice. Laura, what's our ratio or R?
Wait, our ratio?
Yeah,
Is it
looks like they're timesing by 3. She's saying 3. She's saying 3. We have to find the sum of the first 6 here. Yeah, 6. So I think I should put a 6 right there. We don't even have to find those next 3.
We can just put it
Yeah, just calculate this up.
That's nice.
Yeah, it's nice. It's a nice deal. Tell me if you get what the answer book says. 1092. If you don't, we could give you some personal button coaching a little later. I think I should do maybe a number 50. No, I'll do 48. It's harder.
Oh. I did not even get close.
You didn't get your 1092?
No, I didn't.
You got 96.
I got a negative 22.
Yeah, so did I.
Did you put a parentheses here, like that, or did you just put it?
7.8.
1 minus 3.
They're still trying to get their parentheses right.
Got it.
Connor got it.
Wait, let me see. Oh, you just.
Yeah.
It's like.
Right.
Doing work.
I got it.
Oh.
Even Caden got it, and he's been ill.
Tissues.
Baba.
Three parentheses, parentheses, 1 minus 3 is 6 parentheses, divided by 3 parentheses, 3.
Yeah.
go out.
You get homework too.
All right, for this number 48 kind, we've got the big summation symbol again. That means we have to add up what this gives you for ends from 1 through 6. So there's 6 numbers have to be added up here. I could write them all up and do it kind of slow. The first one is going to be 5 times 2 to the 0 power, because if this is 1, then 1 minus 0, plus 5 times 2 to the 1, plus 5 times 2 to the second, plus 5 times 2 to the third, plus 5 times 2 to the fourth, plus 5 times 2 to the fifth. Now you could do that all kind of long and slow and careful. That'll work.
Isn't the n minus 1, or n equals 1, you have to start at 1 instead of 0?
That has to start at 1, the n.
Okay.
So you're right about what you said, but that makes this 0.
Oh, okay.
See? Good point, good point. And so you'll add these up and whatever it is, but there's probably better ways, especially if they had asked for kind of a bigger one, you see. They have a special formula. Well, isn't it the one we just did? Yeah, it's sum of a series. I'm going to use Connor again because he was good last time. Connor, isn't this the series 6, sum of 6 things?
Yeah.
Yeah, he's with me on that. What's the first one?
5?
He's right.
Yeah, okay.
It's 5. A sub 1 would be 5, because that's 5 times 2 to the 0 power, that's 5 to the, he's right. All right? And I think we learned on this last one, you
Go
know.
over that part again, Mike.
Why it was 5?
Yeah, why you
All right, reviewing the 5 for Laura. The first term would be 5 times 2 to the 1 minus 1. That's 5 times 2 to the 0. Anything to the 0 power is 1. So this is 5 times 1, 5. So in the a sub 1 spot, which is the first thing, we're putting 5. Now on the top, we have to have 1 minus r to the 6. Wait, I don't know. There's no r in there. We know what the r is, I think. 1 minus something to the 6th. This is going to be 5. 5 times 2. 5 times 2 times 2 times another 2. What is the r? The audience has correctly determined that r is 2. It's taken times another 2 every time. Why do I keep writing r? No, it's 2. Okay. To the n, so I'm going to put a 6 there, right, Connor?
Yep.
What do I have to put on the bottom?
1 minus 2.
1 minus 2. I'm just going to put a minus 1 there because I think it gave a lot of people fits and extra parentheses and stuff in their calculators. You got it right away, but some people, you know.
Yeah.
Right. Punch that up and see if you can match the answer book for number 48. We'll see if we do a little better this time. It took them several tries last time.
Got it.
Connor bangs up a 315 on the first shot. How about the rest of you?
Yes, sir.
All right. All right.
Oh, you
Dismissed for track? We're going to miss the last part of the lesson.
Lying.
It's okay.
Don't believe in me.
Run fast.
Good luck, Billy and Laura.
Thanks.
Hey, we're taping it. Technically, they need not miss it. It's still here.
It's still here.
The last part of the lesson is one more formula. The sum of an infinite series. Caden will read it off the bottom of 613. Caden, will you read me that formula that's just for the sum of an infinite series? Not yet, not yet. Not yet.
Can I ask where you get the R from?
Okay, Caden.
S equals A1
A1,
all over.
A1 all over.
There we go. That like that.
Yeah.
1 minus R.
That's it?
That's it.
This is an infinite series formula? All right.
Yes.
Here's the deal. Some series that go forever, you can get a total on them because the pieces keep getting smaller and smaller and smaller. For instance, think about a ruler that is 8 inches long. If I just chop half of it off, I've got 4. Then if I chop half of what's left off, I've got 2. 1, a half, a fourth. I could do that forever, have a series of numbers that go forever, and they should add up to blame near 8. Actually, if you say infinite, meaning it goes forever, it's exactly 8. So that's what we're doing, adding up series that get smaller as you go. We're going to try this formula that Caden gave us. We're going to try it quickly on number 56. Okay, I'm going to need Jaden on figuring out the A sub 1 and the R. Jaden, 56 there, are you looking at it? What is A sub 1?
1/20.
He says 1/20th is the first term. Can you see what it's doing, what the ratio is?
It's 1/2.
If you could just figure this out, you could figure out the total of this series that goes forever. I mean, you can never do that one by hand, right? That is the end of today's geometric series and sequences. Goodbye.